I just want to ramble a little bit, divorced from the recent videos about the League of Reason. I just want to take a video break, so to speak, just one of these, and I hope you follow me along this train of thought, because it's still a little ambiguous, and I apologize for that, but this is something I've been trying to wrap my head around for some time. A few of you have gotten in a conversation with me about indeterminism of quantum mechanics. In fact, Piro sent me a video where I was real tempted to just edit out everything he said except when he said quantum mechanics, and I probably would have a 1.5-minute video. He said it a lot, and it seems very pivotal to Piro's particular worldview, that the basis of causal events is indeterminate. And that doesn't sit well with me, and that alone is not reason enough to reject the idea. But I recently issued a couple videos about cellular automata, where we see essentially a model that takes a seed and replicates the seed according to certain simple laws. And what was interesting about cellular automata is that it would recreate things that we observe normally as fractals, but they're not fractals at all. They're different. It's a repeating pattern that we know the algorithm, so to speak, that propagates a particular shape or so on. And what's fun about cellular automata is that you can use it as a model to rediscover the Einstein equations and rediscover quantum mechanics and rediscover fluid dynamics and other such things. I mean, really the very sort of boring kinds of parts of physics, if I may say, to some of the more mind-bending stuff. And one thing that Stephen Wolfram is his name, the guy that does this, or at least he made a program called Mathematica where he uses cellular automata for a number of different things. He didn't invent cellular automata, he just made the program. What's interesting about cellular automata is that to understand the entire universe, like all of existence, physical, possible, non-physical, anything in between, as a cellular automata, we're forced to consider the observer in the same terms. Now, I'm quite a fan of the idea of awareness, and I think of awareness as really the kind of the bridge to any transcendental reality that might actually exist. That all aside, there's this notion of computational equivalence, where that we see, say, something as simple as a pattern on a mollusk shell, mollusk shell. That was kind of a weird accent. And we suppose that through a traditional sense of evolution, that particular pattern on the shell was tweaked ever so finely over many, many years. What might actually be the case is that something like a cellular automata determined that pattern much more quickly than what would be necessary by a traditional evolutionary explanation. Cellular automata doesn't replace evolution, it just supposes that it could happen a whole lot faster in some situations than this kind of awesome length of time that scientists propose. It might be interesting to say young Earth Christians and such, but I wouldn't propose that you could take it quite that far. And really the point is this: our means to know is in philosophy called epistemology. And epistemology has limitations. Limitations now. This is just purely a philosophic discussion at this point. There are limitations to what we know because we know that knowledge itself is separate from reality. We can have real thoughts, so to speak, but those thoughts ultimately are useful to us because they are models of reality, and it may or may not be an accurate model of reality. With that being said, if we are to assume a world that is propagated by something like a cellular automaton, we have to understand even the observer in these kinds of limitations. The idea that even our ability to see, to observe patterns might be limited by a degree of computational sophistication, it's called. The idea is that in cellular automata, normally what we see when we start with a seed and propagate it out, we'll get what's called nesting. And we call it nesting because it's an apparent pattern that emerges from the replication of something in a determined way. Well, every once in a while, we can come up with a set of rules that propagates a seed in a way that has no apparent nesting, meaning it looks completely random. If you were to stop the program, run it again, you get precisely the same picture. That's the important part. But again, it looks completely random. There is no explicit presence of nesting. Stephen Wolfram, the guy who was interested in this kind of thing, proposes that our ability to observe our world is the result of a kind of computational sophistication, and one that can be bettered than or lost to by other things in the outside world. Meaning that if we were to observe something that is operating by a computational sophistication greater than our ability to observe it, then what we will observe is no nesting, even though it's a completely determined pattern. And hypothetically, we would be able to determine a pattern because it's determined. Determine a pattern because it's determined. Did you catch that? Because it's completely determined, we could hypothetically expect to see some kind of nesting, to see that pattern, and in order to then, in the end, discover what those secret rules are that causes the thing to propagate in the particular way that it does. In some cases, that can't be done. Not backwards, anyway. If you start off with the rules, then you can create the picture. But if you just look at the picture, it may be impossible for a human being to figure out what those rules are. Now, when we talk about indetermination in quantum mechanics, this raises some interesting implications.